Find the derivative of g of t equals 1 over t plus 1 cubed times 2t plus 3 squared. So g of t here is the quotient of two different functions, a constant 1 divided by t plus 1 cubed times 2t plus 3 squared, which is a product. Since the numerator is a constant, we are not going to use the quotient rule. Rather, we're going to rewrite this by moving these expressions to the numerator as negative exponents. There's a 1 already up there. We don't need to write that. It's implied. And each of these will now be to a negative exponent. And the derivative will therefore involve a product rule of these negative exponents. Our derivative, g prime of t, will be a product rule. We'll start with the derivative of the first. Now the first is negative 3 power. Bring the power down. Leave the inside alone. Subtract 1 from the power, negative 4. And then multiply by the derivative of the inside, which is just a 1, to complete the chain rule. And you multiply this by the second left alone. Add to this the first left alone times the derivative of the second. The derivative of the second, bring down the power, leave the inside alone, subtract 1 from the power, and then multiply by the derivative of the inside, which is a 2, to complete the chain rule. Our next step, we're going to multiply the constants. I have a negative 3 and a 1. That will give us a negative 3. And I have the t plus 1 to the negative 4 and the 2t plus 3 to the negative 2. And then I have a negative 2 and a positive 2. That will give us a negative 4. And I have the t plus 1 to the negative 3 and a 2t plus 3 also to the negative 3 power. In our next step, we're going to factor. And as far as the constants, we have a negative 3 and a negative 4. What can factor from there is a negative. That's it. So they will become positive 3 and a positive 4. And now I can start factoring out the expressions to powers. Let's start with the t plus 1. I have a negative 4 power and a negative 3 power. You factor out the lower. Well, the lower of those two is the negative 4. That's a lower value than a negative 3. It's a more negative number. So we factor out the t plus 1 to the negative 4. Now what will happen when you factor that out? You're subtracting it. Now for the first term, it's going to completely remove it, of course. But what you're doing is you're subtracting a negative 4, which means you're adding a 4. And negative 4 plus 4 is 0, and that quantity would have been to the 0, and anything to the 0 is a 1. That's why that one disappears. The second one, we're going to subtract a negative 4, which means we add a 4, and a 4 added to a negative 3 is a 1 power, so it's going to take all of it out and leave a t plus 1 to the first power there. It's a little tricky, but you have to subtract what you're factoring out, and we're factoring out a negative exponent. So that will leave us with 3 times a 2t plus 3 to the negative 2, and then plus a 4 times, and we'll be left with a t plus 1 to the first power, as well as the 2t plus 3 to the negative 3 power. Okay, the next thing to factor out is the 2t plus 3. We have the negative 2 power, and we have the negative 3 power. We can factor out the lower. That will be the negative 3. So g prime of t will be a negative. We have a t plus 1 to the negative 4. And now we're going to factor out a 2t plus 3 to the lower power, which is the negative 3 power. Now when we factor that out, remember that we're subtracting a negative 3, which means we're adding a 3. Now, if you add a 3 to the negative 2, you'll get a 1, and you'll be left with one of those there. And then here we'll be removing, by adding a 3, you get a 0, and anything to the 0 is a 1. You fully remove that. There's what you should have left. And so this will give me 3 times 2t plus 3, left over there, plus 4 times t plus 1. In our next step, I'm going to distribute the 3 and the 4. So I have negative t plus 1 to the negative 4, 2t plus 3 to the negative 3. Distributing, I will have a 6t plus 9 plus a 4t plus 4. We can then add like terms together in there. So our g prime of t has become a negative t plus 1 to the negative 4 power, a 2t plus 3 to the negative 3 power. All that's staying the same. And then we have a 6t and a 4t. They will add to be a 10t. And we have a 9 and a 4, and they will add to be a 13. In our last step, we're going to take those negative exponents and we're going to move them to the denominator to make them positive exponents. And there's nothing else that factors, so this should complete our derivative. There'll be a negative of 10t plus 13 left in the numerator, and we have a t plus 1 that'll move to the denominator, raised to the 4th power, and we have a 2t plus 3 that'll move to the denominator, raised to the positive 3 power. And there's our simplified version of the derivative g prime of t.